3.
3, but kind of like
There's-
2B.
Yeah,
Yeah,
there's more pages, but we figure we'll just do 2 pages at a time, so it's not to overwhelm you.
Right.
This is pages 23 and 24.
And these refer back to our lovely prism that we had on the last 2 pages. So we're just really going to be talking about that and talking about the different ways that we went through solving it.
So I drew it here.
It's beautiful.
It's the best.
It is.
It doesn't slope at all.
It's perfect. All right, so it says, look at the model and picture it. There it is. You could turn back if you wanted to in your book.
You need like a perfect model.
But whatever. Okay. Count the number of cubes in one layer. And we did that.
We did do that.
But we get to do it again. Woo! All right. So we have 1, 2, 3, 4, 5, 6, 7, 8. There we go. So there are 8 cubes in one layer. Remember, we did that last time too. So how can we find the number of cubes in one layer without counting them?
Oh.
Let's see. I see something.
Oh, I see it. I see it too.
There it is.
We could look at this length here
And
this width here
Uh-huh.
and multiply 4 times 2.
Which is 8. So we could multiply that length times the width. Wait, that reminds me of something. Didn't we multiply length times width and find something else before?
I think we did. I think it was
Area. There we go. So remember when we only had a 2-dimensional shape? We found that area of the plane figure by multiplying the length times the width.
And we just did that here to find one layer.
Nice. I like it. Okay, so now
Number 3 says, once you know how many cubes are in one layer, what else do you need to know to find the volume? Oh, we need to know how high it is.
that's right. So how many layers there are? And it's height.
Isn't the height? That's what we call
How
it.
tall we are.
We've got length,
Width and
height.
all right, we got it.
So how many layers, which is
Also,
also
AKA, also known as the
the
height. Awesome. Whew. All right, we're getting it. Okay, so now, if we know that there are 8 cubes in each layer, and there are 3 layers, what multiplication expression? Wait, not equation, but expression?
Oh, wait.
Huh.
Equations have an equal sign, and expressions don't.
Oh, but I can still solve an expression, right? But it just doesn't always have that equal sign.
It just doesn't have like an equal sign and a question mark.
Gotcha.
Right.
Okay. So
8 cubes in a layer and 3 layers. Oh, wait, that would be 8
times
3.
There we go. So my expression is just 8 times 3. Perfect.
What is the volume of Abigail's rectangular prism? Oh, wait, 8 times 3 is
24.
But wait, we know the unit of measurement here. It's centimeters. So I can say
24
centimeters
cubed. That's it. We have to have that 3 up there because we multiplied centimeters times centimeters times centimeters. Gotcha. So now, explain how you can use multiplication to find the volume of a rectangular prism. So I think you were onto something when you were over there.
I could multiply the length and the width and then multiply that by the height.
Nice. So that length times the width times the height. Oh, gotcha. So we said that a rectangular prism is 3-dimensional. So we had 1 dimension the length, 1 dimension the width, and 1 dimension the height.
And that's this little 3 right there.
Nice. I get it. Okay, so now they want us to reflect. So, stop and think. What worked best? What way would you want to solve that?
So gosh, there could be lots of different answers for this, couldn't there, Mrs. Croft?
Well, I think we've done it like 3 or 4 different ways already.
We can count all of them. We can count the layers. And then multiply by how many are in each layer. Or we can just multiply length times width times height.
Oh.
So you can write whichever way you actually like. You know what way I really like? Because I'm all about like less is more simplification.
Right.
I kind of like multiplying the length times width times height.
So do I.
So I'm going to write that. But you can write whatever works for you.
Right. If you like to count the number of blocks in a layer and then can multiply that by the number of layers or add that 3 times or whatever it happens to be, then you can absolutely do that. Because that's the cool thing about math. There's more than one way. Nice. So that's one way that we can reflect on that problem. All right, so now let's move on. Let's take a look at page 24.
There it is.
We have a new rectangular prism. It's 1 inch by 1 inch by 1 inch. And it wants us to know, what is the volume of that rectangular prism?
All right, well, we've got a couple different ways we can try this.
Absolutely.
Should we figure out what one layer is, and then we can just multiply it by the height?
Sure, let's do it.
Does that mean we can count? Well, let's look and identify real quick.
Okay,
let's take a
let's
second.
do it.
How many long is this?
It looks
One,
like
2,
3.
3.
Yeah.
I'm going to write 3. No, I'm going to do it down here. It's just,
Ooh, you didn't press the magic
I didn't press it.
Your finger wasn't ready.
Was it ready? 3 inches.
Nice. I like
You
that.
can see how wide it is. It looks like
3 inches there.
And then how tall it is.
3 inches. So it's a perfect cube. 3 by 3 by 3. I like it.
So if I were to figure out how many are in one layer, we decided we could multiply length times width.
You got it.
3 times 3 is 9.
Hey, that's my room number for a change. So 3 times 3 is 9.
It's like this curriculum was built for us.
It is. It's so cool.
Now, maybe we should count just to double check.
Okay, let's try it this way.
Ready?
Okay, we're ready. 1, 2, 3, 4, 5, 6, 7, 8, 9. Woo! We did it.
It's right.
We're good.
2. So we said we do 3 times 3, which is 9. But then we have to
That's one layer, right?
Now we have to multiply by the layers. So times 3 more equals 9 times 3 is
27. That was a good age. Just saying.
It was, actually. I like 27.
That's a long time ago for me. All right, so it's 27
inches
cubed. Oh, right. So it's 3 times 3 times 3. I like it. Okay, so now we have Mr. Wong finding the volume of this box. So he's filling it with 1 foot unit cubes as shown. What's the volume of his box? So, how can we go about solving that one? Yeah, that foot's important, huh? Because there's a big difference between inches and feet. Little big.
I think we should identify how long it is, how wide it is, and how tall it is before we get started.
I like that idea.
So we've got 1, 2, 3, 4, 5, 6
feet. That's even taller than me.
That is tall. That's much taller than me. Let's see. How wide is it? 1, 2.
2. All right. So that's 2 feet. And then how tall is it? What's its height?
1, 2.
Okay. So now we said that we can multiply.
So let's start with length times width. So we've got 6 feet times 2 feet, which equals 12.
Your room number.
My room number.
All right.
And then we have to, we still have to multiply.
By its height, huh?
And you know what I started doing, Mrs. Crum? I started underlining
the
things, the 3 different measurements that I'm using to make sure I'm multiplying 3 things.
That works. I like that plan.
6 times 2 is 12. Times 2 is
24.
You want to hear something spooky, Mrs. Crum? The first year I taught at Sierra View, I taught in room 24.
Oh, see? It is special. It is fun.
And I taught 2nd grade. Weird. Oh my gosh.
That
it's like
is
the Twilight Zone in here. Okay, I feel like this is missing something. It feels not complete.
It is. It is missing something.
We need to show the measurement.
That's right, because it's not inches this time. Now it's feet. So remember, we had our box before. 1 square foot is a lot bigger than 1 square inch, which is a lot bigger than
1 square centimeter. That's what my catchphrase sounds like. All right, Jamila. Jamila wants to find the volume of the rectangular box at the right.
This one.
What is the volume of the box? Gosh, it's not split into little unit cubes, but I feel like we could do it.
I think we can because we can just multiply. There we go.
Let's look. I've got 2 centimeters and 3 centimeters as my length and width.
Nice.
So I could do
2 times 3.
And that equals
6.
And I could take my 6 and I have to multiply it by the height,
which is so it's tall.
6. It is very tall. 6 times 6 equals
36.
And then we know it's centimeters.
So
and we
centimeters
3 things.
Cubed. Good.
But oh no, Mrs. Crumb, I have found this. It says 36 cubic centimeters or 36 cubic inches. It doesn't say centimeters cubed. Wait, do you think cubic centimeters and centimeters cubed are the same things?
Really sounds like it to me.
They sound exactly the same, just different forms of it. Okay, so this one says, I've got the numbers 36 cubic centimeters or 36 cubic inches.
Well, these are centimeters.
So I would have to pick C because it's the right measurement.